25, and we are talking about chords and arcs and sections of circles. And if you think about it, that's actually one of the vocab words we've had on our wall the whole time. Come back. We had chord and we had arc and we have inscribed angles of circles and we have other words related to information on a circle. And so that's what this lesson, this section of lesson videos are all about. So thank you for checking in, clicking on this video, and getting a chance to really wrap up like actually what is a long module, but it's full of good knowledge and you're here for it. Have something to write with, have something to highlight with, maybe multiple colors of the utensils for writing that will help you out. And let's take a look at what launches our conversation on chords. We are in the relationship between chords. We have some vocab words. We've got the diameter chord theorem. We have the equidistant chord theorem. We have the equidistant chord converse theorem. We have congruent chord, congruent arc theorem. We have the congruent chord, congruent arc converse theorem. I had to take a nap. These are going to be awesome that we're going to get into this one. All right, here we go. Some learning goals for the next sequence of video lessons. So highlight them and be aware that these are the things that you need to be able to accomplish. We're going to prove the diameter chord theorem. We're going to prove the equidistant chord theorem and its converse. And then we're going to prove the congruent chord, congruent arc theorem and its converse also. And so those words line up with our key terms. Let's tackle this review. All right, let's see if I can kind of zoom in, center, and enhance here. Yeah, write down everything you know. Write down everything you know about this diagram. So the first one that I see right away is there's a circle. Its center is Q. Circle Q. That doesn't make any sense. Say the word. Circle Q has radius QP. Because it has radius QP, that means that QP and RP, no wait, QP and QR have to be congruent. They're radii of the circle, after all. PR is a chord. Oh, because there's a triangle in the shape. See the triangle here? Those two sides of the triangle are equal. That's QPQR. So therefore, triangle PQR is isosceles. QS, that ray right here, or line if you want to call it, QS is a bisector. Angle PQR, so Q, this angle is being bisected by that bisector. It creates a perpendicular, so QS is perpendicular to PR. I see that from the symbol right there. My notes. Because it's an isosceles triangle inside the circle shape created by the chords and radii, then that means that angle P and angle R are congruent. P is congruent to angle R. I think, and I'm going to go out on a limb here, but I might be wrong, but I'm going to assume that I'm right, that PS and RS are congruent. So add to the list, PS is congruent to RS. The angle, okay, the measure of arc PR is equal to the measure of the angle PQR. Remember that one? That was the whole idea of central angles. It's off screen, I guess, right here, right? Central angles and the arc created by the central angle, the intercepted arc. What else do we have? Some notes. Oh, there's two triangles. There's this triangle on this side and this triangle on this side. So triangle PSQ has to be congruent to triangle RSQ. That should be true because of SAS, side angle side. The angle that they have in common is the 90 degree. The sides they have in common are RS, PS, and the other side they have in common is QS. Both of them share QS. What else do we know about this shape? We've got an arc, we've got angles, we've got would that be anything? No, that wouldn't be. I'm going to leave the list at this right now, maybe like come back to it or know that like when you look at a diagram, it's just not enough to be like, two things and you walk away. No, you need to identify as many things either up here in your mental powers or write them down so you can visibly see them. Add some color along the way so that we know when we're talking QR, where's QR? It's right there. Where's QP? It's right there. And some extra highlight color can help kind of pop in like information that will stand out so you can do something with it. QS bisects the angle Q. And so the more color you have for any of our lessons, any of these comments, the better off you'll be. So I'm just going to show you that I have 4 highlight colors, and I'm going to highlight random things. But I'm going to try to highlight so that your brain goes green, green, see it. Yellow, yellow, see it. Orange to orange, got it. Pink, I've seen it. Okay, what else? I got some extra color here. There's a triangle. It's congruent to a triangle. So you're sketching in. You gotta add your information to the diagram. Thank you for watching page 425. Get ready for the next video. It's going to be on page 426 as we talk about chords and diameters and other lines that are created in a circle. Thank you for watching. See you in the next video. You are awesome. Bye.